There are people walking around right now who have never felt pain. Not high-tolerance people, not people who push through it. People who have broken bones, burned their hands on stoves, bitten through their tongues in their sleep, and felt nothing. Zero signal. Not brave, biologically incapable of receiving the message. And the wild part? For most of them, this isn't a superpower. It's one of the most dangerous conditions a human being can have. Here's what should stop you. Pain has a purpose. It's the body's only real-time damage report system. And without it, you don't know when to stop walking on a fractured ankle, when to move your hand off a burner, when something internal is catastrophically wrong. People with this condition, congenital insensitivity to pain, or CIP, routinely die young. Not from the condition itself, but from the accumulated damage of a lifetime of injuries their body never flagged as injuries. The inability to feel pain is, functionally, a slow and undetected pure physical violation of every tissue in your body. So the question this video is actually asking is, what's broken in these people's biology? And what does it tell us about how pain works for everyone else? Pain starts with nociceptors, nerve endings that detect tissue damage, heat, and pressure. They fire an action potential that races up the nerve fiber to the spinal cord, crosses into the dorsal horn via substance P, climbs to the thalamus router, and gets processed into the full experience of pain. CIP is what happens when that chain breaks permanently at the genetic level.
But it doesn't always break at the same point. Multiple different mutations produce the can't feel pain outcome through completely different mechanisms. CIP isn't one condition, it's several separate conditions that share the same headline symptom. The most well-understood version involves SCN9A, a gene coding for a sodium channel called NAV1.7. Sodium ions rushing through nerve membrane channels create the electrical signal carrying pain information. NAV1.7 is the ignition switch that lets the pain signal fire. Certain SCN9A mutations produce a NAV1.7 channel that simply doesn't function. The nociceptor detects damage, the sensing machinery is intact, but when it tries to fire, the channel doesn't open. The signal never launches.
A fully wired fire alarm with a broken trigger. People with these mutations feel completely normal otherwise. Touch, temperature, pressure, all intact via other sodium channels. Their nociceptors look structurally normal under microscopy. The hardware is there. The software update enabling pain transmission just never ran. The flip side, gain-of-function mutations in SCN9A, where NAV1.7 becomes overactive, produce primary erythromelalgia, spontaneous, excruciating burning pain with no external cause. Same channel, opposite mutation, opposite outcome. NAV1.7 is a 260-pound bruiser that can be permanently asleep or permanently raging with no stable middle setting.
Different mutation, different mechanism. The PRDM12 gene is active during fetal development, overseeing the construction of nociceptor neurons. When PRDM12 is mutated, those neurons don't develop correctly, or at all. People with PRDM12 mutations don't have broken nociceptors, they have absent ones. Skin biopsies show dramatically reduced or completely missing nociceptor nerve endings. The chain doesn't fail to transmit, it was never built. This version also strips temperature sensation. The same developmental pathway that builds nociceptors builds neurons for detecting temperature extremes. So PRDM12 patients frequently can't tell hot from dangerously hot. The developmental blueprint for detect threats to tissue got corrupted at the template level. The most severe form is CIPA, Congenital Insensitivity to Pain with Anhidrosis. Same pain insensitivity, plus the inability to sweat. The mutation is in NTRK1, a gene coding for a receptor involved in the development of autonomic nerve cells that control sweat glands and the nociceptors that share the same lineage. Without sweat, the body can't regulate temperature. CIPA patients can overheat in mildly worn conditions with no warning. In early childhood, before the condition is understood, this is frequently fatal.
temperature dysregulation combined with undetected injuries creates a body quietly destroying itself from multiple directions, making CIPA one of the most dangerous rare conditions on record. The discovery of NAV1.7 sent pharmaceutical companies into a flop era of excitement.
Block NAV1.7 temporarily, the way CIP patients have it blocked permanently, and you'd have a painkiller that eliminates pain without touching motor function, cognition, or any other system. The problem? NAV1.7 is expressed not just in nociceptors, but in olfactory neurons. Early NAV1.7 blockers knocked out the sense of smell alongside pain. Medically tolerable, commercially unattractive. Getting selectivity for nociceptors only has proven technically brutal. The research is ongoing, and CIP patients are the proof of concept that keeps it funded. Living demonstrations that pain can be removed specifically without compromising the rest of nervous system function. The conglomerate of all human knowledge about pain pharmacology owes a real debt to people born unable to feel it. CIP cases with identified mutations, SCN9A, PRDM12, NTRK1, represent only a fraction of people with congenital pain insensitivity. A meaningful percentage of CIP patients have no identified mutation. Genetic sequencing finds nothing in any known pain-relevant gene.
There are pathways, channels, or developmental mechanisms involved in pain sensitivity that we haven't mapped yet. Pain insensitivity can also be acquired. Leprosy progressively destroys nociceptors, producing the same accumulated injury pattern. Certain autoimmune conditions attack sensory neurons specifically. Pain insensitivity is achievable through multiple routes, not just the genetic ones we found. And underlying all of this, we understand pain signal transmission reasonably well. We don't understand why the same signal produces wildly different subjective experiences in different people. Why a paper cut is trivial to one person and distressing to another. The signal chain is the same. The experience is not. That gap is a philosophical path unknown neuroscience is still circling without being able to land on. So, some people can't feel pain because their sodium channels don't fire. Some because their nociceptors were never built. Some because their entire autonomic nervous system took the same developmental hit. And a meaningful number have none of those mutations, and we simply don't know why. Every one of them is simultaneously a medical tragedy and the most important research subject in pain pharmacology. The inability to feel pain looks like a superpower until you understand that pain is the only thing stopping your body from quietly falling apart without your knowledge. You made it to the end, which means the exit fee is due. 1 subscribe, that's the toll. I'm flipping this tablet around like I'm expecting a tip, and you're paying it in the form of a like. Don't, and I'm assuming your MHC molecules are incompatible with mine. And with your NAV 1.7 presumably functioning correctly, that rejection is gonna sting. Stay wrinkly, Apes.